we have our final intended learning outcome. That's ILO3, which is to solve equations and display results for simultaneous equations using IT. So this is going to progress the work that we did in week 5, where we solved simultaneous equations using graphs. And now we'll work to try to redo the questions. However, this time we will use IT and Excel to display the graphs. So, example 6, 8.6. Solve 8x minus 3y is equal to 39. That's equation 1. And equation 2 is 7x plus 5y is equal to minus 4. So the first thing we do is we rearrange to make y the subject of both equations. For equation 1, we have 8x minus 3y is equal to 39. Then what we have is minus 3y is equal to 39 minus 8x. So we've gone and made y being the subject of the equation there. Now to get y on its own, what we do is we divide across by minus 3y, which gives us 8x minus 39 over 3, which gives us y is equal to 8x minus 39 divided by 3. So that's equation 1. So for equation 2 we have 7x plus 5y is equal to minus 4. Once again, rearranging to make y the subject, we have 5y is equal to minus 7x minus 4. And now if we just want to get y on its own, we divide by 5. So we get y is equal to minus 7x minus 4 divided by 5. So this is what our answer is for equation 2 in terms of rearranging it to make y the subject. So the next question is, if we want to go and solve these simultaneous equations, what's our next step? Well, of course, what we did before was we would draw two tables and insert values for x and then solve for y for the corresponding values of x. So we do this for both equation 1 and for equation 2. So now we want to have a go at doing this using Microsoft Excel. So here's a hint for you. First of all, create the table as follows. In B2 and C2, enter the formulas. So in column A, enter the values for x, where x is equal to minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5, 6, 7 and 8. So enter those in the list down. Then, as I've said, in B2 and C2, enter the two formulas for equation 1 and equation 2. So then, when we're looking to go and extrapolate the formulas, what we do is we replace x with A3 in both cell B3 and C3. And then, if you select one of the boxes and if you drag the cell down, it will automatically fill down the answers for each of the cases of when x is equal to minus 3, minus 2, minus 1, 0 and so on down to 8. So we now draw the graph, and use it to read the intersection point. So here is the example that we've worked out, and I want you to have a go at getting this solution using Microsoft Excel. If you have questions as you're going through this, feel free to ask your fellow students there who may be able to help you out and clarify various questions that you have. Also, feel free to email myself or Glenn, and we'd be more than happy to help you. So you can see from the graph of equation 1 and equation 2 that the intersection is when x is equal to 3 and y is equal to minus 5. And you can also see that from the table as well as from the graph. So now what we want to do is we want to test this knowledge for another example. So example 8.7. Solve the simultaneous equations 4x plus 2y is equal to minus 24 and x minus 3y is equal to minus 13. The first thing you should do is make y the subject, so we rearrange the equations. Then create the table in Excel, and following this enter the formulas for the two equations. The next step then will be to draw the graph and use it to read the intersection point. So have a go at this. If you want to pause this video now, attempt the question, and your solutions will be checked in next week's class. So print out the solution and bring it with you to next week's class. So that completes intended learning outcome 3, ILO3. So now you can solve equations and display results for simultaneous equations using IT. So once again, well done. You have now completed ILO3, and the next step is to go to the closing video, where we will do a quick refresh and send the context for next week's lecture. Thank you.